This is the first of two videos where I talk about graphing inequalities. In this video, we're going to talk about the skills of graphing inequalities, what you need to know, what you need to be good at. In the second video, we're going to really talk about where you're going to see most of the problems, the systems of inequalities. In that video, we're going to talk more about strategy, so I wanted to split it up. Skills, then strategy. You need the skills to be able to execute the strategy. All right, so there's two steps in graphing an inequality. One, graph the line. Two, shade. Shade. Okay. Let's go ahead and draw some axes up here and just do a couple easy examples. Let's say that I have y is equal to x, inequalities. Y is greater than or equal to x plus 1. So, not too bad of a line to graph. Y-intercept of 1, slope of 1, will look a little something like this, right? Okay. Y is greater. Where is y greater? Above the line, right? Above the line. Above the line. So we're going to shade above the line. Shade above the line. So what is this telling you graphically? Well, it's telling you that all of these values are valid answers to this inequality. Basically, for all these values, including this line, because it's equal to or greater than, that's going to be a good solution for this inequality. Any one of these points that's in the shaded zone, including the line. Now, we left the line solid here because it's greater than or equal to. So when it's greater than or equal to, less than or equal to, it's solid. It's a solid line. It's the second little sub-step of graphing the line. Let's look at another one. Let's say y is less, oops, that's a greater than. Try that again. Y is less than 2x minus 1. Okay? Another relatively straightforward line. I know my drawing's not the best, but I try to use on-screen diagrams whenever we have those in problems, and I draw diagrams just to show you how effective your own diagrams can be, even if you're terrible at drawing like me. So, 2x minus 1. All right, so y-intercept negative 1, kind of a steeper slope, right? Something like this. Downhill. X is below, downhill, beneath. But first, we got to deal with that line. So the solution for this won't include that line. So what do? Dash, 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 dash. Dash the line. So if we have greater than or less than dashed. No line, not solid line, basically, is one way I've had people think about it. So again, we just said that y has to be downhill, so we shade this downhill. So all the solutions for this inequality are going to be where these things run into each other, right? Where there's a coordinate point in this blue zone that's not on the line. That's how those work. Let's look at a couple special cases, horizontal and vertical lines, and then we're going to hop into an ACT problem. All right, let's say we have y equals 2. Now, when you have y equals and there's no x, that's a horizontal line. One way you can think about it is y is like the up and down, the vertical, but when you have just y equals, it's going to be the opposite. It's going to be the horizontal. Basically, what the equation is saying is that y is always 2. Because y is always 2, there's never any variation in it. There's no slope, right? You could rewrite this in y equals mx plus b as y equals 0x because there's no slope. Because y never goes up or never goes down. There's no rise. So for all the run, and there's a ton of run, infinite run, There's no change. So 0x plus 2. All right. Whoop. Whoop. Now, if we have an inequality, let's say y is greater than or equal to. Well, when is y greater than? Uphill, right? There you go. Let's look at vertical lines. I think that's actually the one that people have trouble on. Vertical lines have what's called an undefined slope. There's no run. So you would be dividing infinite rise over 0 because it never goes anywhere. And like I said, it's kind of opposite, right? So instead of y equals was our horizontal, x equals is our vertical. Let's say x equals 2. So that would be this line. Now, if I want to change this into an inequality, let's say x is less than 2. Well, first I got to dash my line, right? Dash, 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 dash. And when is x less than this? Well, it's over here. X is less than on this side. So I'll shade all this in, and that's my solution set. Okay. Now, let's hop into this ACT problem. Here's our ACT example for graphing inequalities. It's a very straightforward problem, and in fact, it has more to do with knowing what line equations or how line equations work than it does with inequalities. They want to know what the signs of A and B are, right? They give you this inequality, y is less than ax plus b. What would be the signs of A and B? We have our inequality graphed and shaded. It's also got the dotted line. Everything is done except for the first step in graphing inequalities, the line stuff. So let's look. Now, I would look at B first, but you can look at A first. It doesn't matter. And B is the y-intercept, right? Y equals mx plus b. And that is most definitely positive. So I want to mark off anything where B is not positive. So B is negative here. B is negative here. And E, I'm going to go ahead and mark it off. I'm going to say that, well, I know I can determine this. I know I can. May not know what the slope and the y-intercept are, but I can tell what signs they'll be. Let's go on to A. A is the slope. A takes the place of M. And A falls, or line falls, from left to right. That means A is going to be negative. So I'm going to eliminate anywhere that A is positive. And I'm left with answer A. That's all there is to this one. But remember, this is a skills video. The meat of the problems will be in the second video, graphing systems of inequalities. So make sure you check that one out.